Solve the equation for the indicated variable a equals 1/2 h times the quantity capital B plus lowercase b. Now, when we're solving for an indicated variable, we look for exactly which variable they're asking us to solve for. In fact, this equation, since it's got a on one side of the equal sign, a appears only on the left side. I don't see any a's on the right side. And the a itself has got a coefficient of +1, an invisible coefficient of +1. This equation is already solved for a. So I look back and say, okay, now what variable are they indicating what they want me to solve for? They want us to solve for b. So keeping the goal in mind, our goal would end up being, we want capital B. In fact, there are two b's in this problem. Specifically, they want capital B on one side of an equal sign, the equal sign, and all the stuff, for lack of a more sophisticated way of saying it, all the stuff that's not capital B. This might be the way to best say it, and in layperson's terms. So the goal of solving for an indicated variable is to get that variable on one side of the equal sign and all the stuff that's not that variable on the other side. Now, B appears on the right side. It'd be just as great to leave B on the right side, as we're getting everything that's not B on the left side. All the stuff that's not B, let's just move it over to the left side. Let this be our goal. And then we can just, once it's solved for B, we can flip the two sides around and make them look like these answer choices that are provided to us. Okay, first first thing that we should think about, I think, is consider how all these factors that are connected to B, how they're actually connected with operations of arithmetic. 1/2 times h times the quantity b plus b, and then b and b are connected inside this quantity with addition. So the way things are connected are going to allow us to disconnect them and ultimately send everything that's not b to the left side of this equation. Okay, one of the most convenient things we can do is notice that this equation, this formula, equations that have multiple variables, we also refer to them as formulas. This formula contains a fraction. When we have a fraction in an equation, a single fraction in an equation, the LCD is very easy to calculate because the LCD is that single denominator. Now, one of the convenient things we can do to an equation is to eliminate all fractions. So we multiply both sides. The 2 can also be represented as 2 over 1. So I'm saying on this side of the equation, we multiply by 2 over 1. This is in an attempt to eliminate all fractions from the equation, and we also multiply by the LCD on the left side to balance the equation out. We multiply on the right side to eliminate the fraction. We multiply on the left side to keep the equation in balance. Here's what would happen at this point. The 2's would divide each other out, leave 1's behind. So what we have at this point is 2a equals h times the quantity b plus b. Now, there are several ways we could go from here. We could divide by h, but I notice that the look of the format of the number of the choices, it appears to me like the person who wrote this problem for this exercise went ahead and distributed. I'm just saying there's more than one way to proceed from here. Dividing by h is a totally fine way to do it, but the answers look to me like the person who wrote the answer set distributed the h to each of the terms inside this quantity. So we arrive at this. H times b, if we wrote them in alphabetical order, would be bh, capital BH, and then h times this other b would be little b h. So now if we completely write the formula, what we've accomplished is we've simplified the right side by removing the parentheses through use of the distributive property multiplication. Now, keeping in focus that we're trying to solve for b, I'm keeping b in mind. This is what we want to solve for, right? So what we should do is keep this term, if we want to keep, keep it on the right side of this equation, then we should consider at this point eliminating the little bh term. Eliminate it, turn it to a 0. Well, this red BH is connected to the big BH term through addition. We're restricted, the way two things are connected together. Addition restricts me to using add or subtract to use this BH against itself. Now we consider that the BH is positive. Positive BH. What would I do to either add BH or subtract BH to eliminate the BH term? Well, plus BH, positive BH, minus BH, wouldn't that become 0? Okay, that's what we're going to do. And then, of course, what we do to one side of an equation, we must do to the other. We subtract BH to keep the equation in balance. Now, these two are not like terms, so as we read them from top to bottom, we're going to write them from left to right. So 2a minus BH equals, we're not going to leave anything behind, capital BH plus 0 or minus 0, it won't matter. When anything plus or minus 0 stays itself. So we have BH equals, capital BH equals 2a minus little bh. And in the end of this, because we're almost done, what I see here is that we have the opportunity now of disconnecting h from b. The way b and h are connected is with multiply. The only tools that are compatible with multiply are multiply or divide. And it turns out that if I multiply by h, which is, I'm trying to get, use the factor that we're trying to get rid of, use it against itself. So we're going to select h to operate with. I can either multiply by h or divide by h. What's the magic operation? Divide, because anything divided by itself makes 1. Here's that 1. Dividing h by h, these are going to divide each other out and make that 1 that we're interested in, because they leave 1's behind, like this. The consequence of dividing and making a 1 out of the h is that we balance the equation by dividing the other side of the equation by h. So here's what we have. b times 1, or commutative property allows us to write it as 1 times b. On the left side we have 2a minus bh, little bh, over h. And if you notice, the capital B only appears on the right side with a positive 1 coefficient, does not appear at all on the left side. So this is all the stuff that's not b, is what we wind up with on the left. So I look at the answers, we could obviously flip these back around, make it look like just like the answers. B, 1 times b is b, anything times 1 is itself, equals, I'm just flipping around the sides, 2a minus b, little bh, over h. This looks to me like it's just a fine answer. And I'm looking at through here at the answers that have 2a in the numerator. This guy doesn't have any denominator, so that can't be right. This guy doesn't have a 2 next to the a. It's going to be one of these two. 2a minus bh, there's this expression, over h. So the plus in this one is wrong. So we can use a little bit of process elimination and arrive at C is the correct answer if this was a multiple choice test or a multiple choice exam.